Welcome to our episode today. We're diving deep into a hot topic in social and personality psychology: statistical power analysis.
That's right, Alex. Over the past decade, the field has faced some tough criticism, especially regarding small sample sizes. That's where power analysis comes in. It tells us whether we have enough participants to detect a real effect.
Exactly. In short, a higher-powered study means a better shot at spotting a true psychological effect. But the real story lies in the debates and challenges surrounding how we use power analysis.
Let's unpack the first major debate. What effect size should we use in power analysis?
This is tricky. When starting a new study, it's hard to guess the size of the effect. So, researchers often rely on Cohen's classic categories: small, medium, large. But these are subjective and don't always fit every study.
Plus, published effect sizes are usually inflated due to publication bias. Studies with big, significant results are more likely to get published. That skews our expectations.
Even pilot studies can lead us astray. And defining the smallest effect of interest isn't always straightforward. A small effect, like aspirin reducing heart attack risk, could still have major implications.
Right. And sometimes our theories aren't strong enough to predict anything beyond the direction of an effect. In those cases, even a tiny effect could still matter, but detecting it might need thousands of participants.
That's where the idea of practically significant effect sizes comes in. For applied research, it might mean a small change in donations for a charity is still worth detecting.
And for basic research, it could mean only detecting effects that a typical lab can afford to follow up on. No need to chase D each 0.05 if you don't have a stadium full of participants.
Now let's jump to debate number 2. Is power still useful after a study is done?
Great question. A lot of folks make the mistake of running a post-hoc power analysis using the effect size they just found, but that's often meaningless. It just mirrors the p-value.
Instead, a better approach is sensitivity analysis. Ask, given my sample size, what's the smallest effect I could have detected with 80% power?
It's also useful in spotting selective reporting. If a series of studies all show significant results, but power estimates say they shouldn't, that's a red flag.
And remember, studies with low power are more prone to false positives. So even if a result is significant, if the study is underpowered, we should be skeptical.
That brings us to debate 3. Do power criteria unfairly penalize some research designs?
Absolutely. Research with hard-to-reach populations, like minority groups or special clinical cases, often can't hit the usual sample size benchmarks. That's a real challenge.
Solutions? Focus on bigger effects, use stronger manipulations or within subject designs to boost power, or even collaborate across labs to pool data.
And let's not forget, qualitative research or descriptive statistics can still provide valuable insights when inference isn't realistic.
Editors and reviewers also have a role. They should look at whether the study was designed to detect its key effects and interpret findings accordingly.
Finally, debate number 4. Should 80% power still be the universal standard?
It's a helpful rule of thumb, but not a sacred number. Cohen picked it based on a cost-benefit assumption, type 1 errors being 4 times worse than type 2.
But there's no scientific law behind 80%. In some fields, like medicine or high-stakes policy, a higher standard, like 90% power, might make more sense.
Especially in pre-registered studies where the cost of getting it wrong is high.
Thanks for tuning in. If you're designing a study, think beyond the p-values. Think about what really matters.
See you next time on Methods That Matter.